Okay, welcome Haley and welcome Josh and welcome Jacob. This is week 5 and it's a webinar on the Central Limit Theorem. I want to make a couple announcements before I go and before I get into the Central Limit Theorem. So first is thank you for submitting your projects. My plan is to get them to start working on them tomorrow. They take a long time to read through and grade and stuff. So I'm really fast about grading for other things, but projects take me some time. So, but I'm still faster than a lot of other people. So I will grade them by the end of the week for sure. And I just finished the discussion post from last week. Finished grading that. That was kind of a quick little project today. And I got those done. Most of those were good. But always read my comments. Make sure that if you're making mistakes or something, you kind of get the idea here. And I want to remind you the discussion posts are the best study tool for the midterm because they actually involve writing and graded writing. Whereas the quizzes are good, but they don't have a writing. And so you want to really pay attention to discussion posts. Second is that due by this Sunday is the online exam. So a lot of you might have forgotten about that. It's chapters 1 through 6. So it's on what we've already done. And the online exam is a lot different than the midterm. One thing, it's not a written proctored exam. It's really coming from the quiz kind of questions that you've been doing. Okay, in fact, it's exactly coming from those. And a couple things, though, that are different than the quiz. First, it's much longer. So expect, I think, 50 questions. It's going to take some time. And second is you're only allowed to try each problem once because it really is supposed to be more like a quiz or, an exam. And in a regular exam, you only get to try every problem once. So that's just a note. Give yourself enough time to sit down and do the problems and pay attention to each of them. You don't get a second chance because I try to make it a little bit more authentic in terms of what an exam is like. And when you take an exam in class, there's no retries, right? So I try to make this like that, is there's no retries. Whereas the quizzes are more, the homeworks are more practice. And with practice, you get lots of retries, as many as you want. So that's just a note. But give yourself time. Don't wait till Sunday night because it's a long quiz, a long exam. So be ready for it. It's not timed, but again, if you don't give yourself enough time, it doesn't matter. So I answered Josh as he was typing, I answered your question. So it's not a time test other than the fact that you have till Sunday night. So after that, it's over. So that part of it's time, but otherwise it's not. Okay, but make sure you sit in a quiet place, give yourself some hours to work on it, and then go and do it. Okay, there's not a whole lot of stuff going on this week. Your discussion project, your discussion forum post is as easy as you'll ever get, so appreciate it now. Those of you who've seen, hopefully you agree. There's no statistics to do. It's just a nice thing. You should all get 100% on that. But don't forget to turn it in by Thursday. And there's one chapter, chapter 7, which takes some work. So there is chapter 7 to work on. And otherwise, you're focusing on this online exam. Are there any questions about it? Any more questions? Any questions? Okay, if there's no questions, let me talk about the new chapter. Okay, and that's chapter 7. Chapter 7 is the big theorem of the course. And we've been spending time preparing for it. So chapter 6 was all about the normal distribution, but there was no reason to believe you ever cared about the normal distribution. It's just some weird curve. It looks pretty, I guess, but why would you think that that's an important curve? And it turns out from chapter 7 that it is the curve, not just important, it's the curve of statistics. Anytime you do a study with a large sample size, then the sampling distribution, which I'll get into in a bit, is always approximately normal, which means that we're allowed to use this normal curve, which is really important because if we just had any old distribution, there is no calculator button that says any old distribution probability, right? That's just won't happen. But there is a normal curve distribution function. So once you know that it's normal, then we know how to handle normal. And that's kind of the big reason why it's really called the central limit theorem. It is the center of all statistics. Okay, and in fact, if you get into like really deep physics and chemistry, you'll find out everything is normally distributed in the universe. So not only is it important to us, but if there's intelligent life out there in the universe, they all understand it. So that's kind of cool. They know the central limit theorem. They don't know the language we're using, but they know what the bell-shaped curve should be, because it is the rule of the universe. Kind of important. Okay, so that's the biggie, and here's what it says. I think I'll share the screen a little bit just to do a little paint so I can actually type a little bit about what it says, and then I'll get into some example questions. Okay, so hopefully you can see my chat, not chat, my paint screen. And what it says is that there's a few things. First, we have seen a lot of different letters that involve means and standard deviations and stuff. So I want to remind you on all the different ones, and we'll talk about the two new ones. Let me do it this way. Let's do it in red. So the first thing, we have that guy. What is that? See if you put in your chat box what that is. So what is that symbol? How do you even read it? And then what does it represent? Yeah, it's mu. So you read it as mu, and it's a mean, but it's a special mean. It's not any mean. We have lots of means now this week. So what kind of mean is it? Starts with a P. That's a hint. Population mean. It's typically the goal of everything, and it's the most depressing part of statistics is you can never get exactly your goal, but you can always seek for it. So it's a population mean. Typically, it's the mean of like the whole country, and you can't ask everyone. Okay, so you also have one more symbol I want to write in, or one of the many that I'm going to write. You have this guy. What is that one, and what does it represent? What is that guy? Standard deviation, but it's a special kind of standard deviation. Not sample, actually. Definitely not the sample standard deviation. We'll get to that later. Here's a hint. Starts with a P again. I don't see you all chatting in at once. Yeah, it's a population standard deviation. Any questions on that? Okay, then we got the next one. X with a bar on top, and we read that X bar. And what is that? So what is X bar? Again, this is all supposed to be review, but it's really important. That's why I want to reiterate all this stuff. What's X bar? Put in the chat box. It's the mean. What kind of mean? It's not the population mean. That was mu. Yeah, it's a sample mean. Any questions so far? Okay, then the next one, actually, I can just type it in. Then we have S. And what is S? Yeah, what is S? Yeah, it's a sample standard deviation. Any questions on the stuff that we've already done? This is all review from earlier chapters, but you need all this to understand the next two biggies. The next two biggies are the ones that are most confusing. So typically what we do is we take a sample. And what we do is we look at the mean. And we want to say, well, how good are we at guessing the population mean? So in other words, if we're in the business of sampling, so we're going to sample over and over and over again.
Those Keys Boulevard, but
Hello? So we're going to sample over and over and over again. And we're going to look at the sample mean every time. And we're going to look at all possible sample means. And we can take the average of all those possible sample means. And that'll be a number. So let me write down how you write that. So it's the population mean of all possible sample means. So what we say is it's mu sub x bar. So let me write down what that is in terms of the definition. That is the mean of the sampling distribution. Any questions about that? Very important. So the mean of the sampling distribution. It says all possible samples of a specific sample size. You look at their means, and then you average them, and that'll give you the mean of the sampling distribution, or mu sub x bar. Then we also have the standard deviation of the sampling distribution. You look at all the possible means, and you take the standard deviation of all those means. And it shouldn't be a surprise that you're going to use sigma for standard deviation, and it's of the sampling distribution, or of the sample means, so it's sigma sub x bar. Any questions so far? That is the standard deviation of the sampling distribution. It also has another name, which is called the standard error. So mu sub x bar, what would you take off a large cluster survey? I'm not sure what you mean by that. So mu sub x bar, what you would take off a large cluster survey. Really don't understand. Maybe someone else could help me if they understand what Josh means. Yeah, lots of samples, but not just lots of samples. This is all theoretical. It's all possible samples. So it's not just the word lots. It's not just, a bunch of random samples. It's every possible sample. This is all theoretical. You can never actually do every possible sample in the real world. So if you're going to do a sample of 50 out of America, then there's going to be 50 to the 330 million different samples that you could do. And that's not even possible. Okay, that's like more atoms than there are in the universe kind of thing. So this is all done in theory, but it's important. Okay, then comes the big central limit theorem. And the central limit theorem gives you 3 results. The first result is that mu sub x bar is equal to mu. So if you look at all possible sample means, you take an average of those sample means, you'll end up with the average of the population. Any questions on that idea? The second one is that sigma sub x bar is equal to, you might guess it's sigma, but it's not, okay, which is actually a really good thing. One of the things about sigma sub x bar, it measures how varied sample means are from the true mean. And what you want is you want to take a sample mean, and you don't want it to be far off from the true mean, because you're going to use your sample mean as your best guess for the true mean. Does that make sense? So you'd like it to be small, and the good news is we can make it small because of the central limit theorem. And what it says is that sigma sub x bar is equal to the original standard deviation, sigma, and then we divide by the square root of the sample size, n. So if you have a large sample size, then sigma sub x bar will be small. If you divide by, say, square root of 10,000, that's dividing by 100, and then now you probably have a very small sigma sub x bar, which means that your mean that you got from your sample mean is likely to be close to your population mean. And that's the goal. You want to take a sample and say that we've looked at the sample, and now we can say something educated about the population. Okay, if you have a small sample, like a sample of size 4, then you're not reducing sigma very much. And then your mean from the sample mean is not that likely to be close to the population mean. So the goal is to try and get a large sample so that you have more reliable data. That way, when you take the large sample, you took a sample of maybe size 1,000, and you can say, aha, I took a sample of size 1,000, therefore, my sample mean is very likely to be close to the population mean. Any questions on that? Okay, and these are, by the way, are true regardless of the sample size. These are always true. But then there's something further. One of the things we want to talk about probability. And if you look at all the different possible sample means, you can draw a histogram. And you want to look at that histogram and say, well, what is the shape of that histogram? What is the distribution? And the good news is that the distribution is a nice distribution. It's one that we've seen before, which means we can use our calculator, because the calculator can have a button to calculate that. Whereas if you didn't know the distribution, the calculator wouldn't know. So here's the third statement, and it's the following. If the sample size is large, and in our class, we're going to call that larger than 30. Okay, and that's kind of standard, larger than 30. Sometimes you'll see 25, but 30 is better. So larger than 30, then the distribution, the sampling distribution, is approximately normal. Okay, Haley, yeah, better to drive without looking on your smartphone, that's for sure. Okay, but hopefully you'll get home and then we'll continue on. Okay, so sampling distribution is approximately normal. So that's really important, because if we know the distribution is approximately normal, then we know how to handle it in terms of finding a probability. Any questions on this idea? This is called the Central Limit Theorem, and it's really important. Okay, there's a few more things, and that is if you look at totals instead of means, that's multiplying by n, so that the total will be n times mu. And the total standard deviation, if you multiply by n, you get sigma times root n, because n over root n is root n. You probably remember that from algebra. Okay, when I say you probably remember it, I know you probably don't, but at least you, I could hope you might have seen it once in your life from algebra. N over root n is the same as root n. Okay, so we'll use that in a little bit. Any questions on the central limit theorem? So this is the biggest result of all of statistics, okay, of any class in statistics, but of course our class too. So this one you need to know. First, you need to know what all the symbols mean. That's not central limit theorem, that's just a dictionary. But these 3 points, mu sub x bar is mu, sigma sub x bar is sigma over root n, and if the sample size is large, and we're going to call it larger than 30, then the sampling distribution is approximately normal. Okay, and by the way, if you're larger than 30, it might be a little jagged. If you're larger than 100, it's pretty clearly normal. But 31 is good enough to use. And hopefully I put in a little bit of memory into you guys. You've seen, when did you see where you had to have a sample size larger than 30? It was supposed to be subliminal. Yeah, so that was in your project. Okay, and when you were doing your project, you just did it because I told you to. Now you know why. So whenever you do any kind of sample, what's quantitative, notice these are quantitative, otherwise you can't even talk about mu and sigma. Anytime you have a quantitative survey, then we're going to be making sure that we have greater than 30, and that way we can use the central limit theorem to show they're normal, and then we can find probabilities. If it's a yes-no question, it's not over 30 you need. It turns out you need the number of yeses greater than 5 and the number of no's greater than 5. Okay, at least expected yeses and expected no's need to be greater than 5. So if I ever ask a yes or no question and I say, you know, how big a sample size do you need? Do not write down 30. Figure out how many yeses and no's, and you need to make sure they're both bigger than 5. And then you say you're okay because the yeses were bigger than 5 and the no's were bigger than 5. Does that make sense? Okay, so let me erase all this. I know it's important, but I only have one screen. So hopefully you took notes and you have it. Let me ask you, I always like to wonder, do you watch the chapter video first or do you watch the webinar first? Put in your chat box, just so I know where you guys are in terms of, is this review or is this first time you've seen it? Webinar, then video. So Josh, you haven't seen it before, which is fine, by the way. Okay, webinar first. That's what I figure. If I don't talk about this first, you will be so lost in all these problems. So I need to go through this piece. But I got to erase it. Okay, so I got to erase it so I can pop in some questions. Because again, we only have a limited screen size. So now let me pop in some questions. Let's see if it'll do it for me. Ooh, that's awful. Let me do it. Let me change the font. One more try. Sorry about that. That's better. Okay, so here's what I got. Okay, so what we have is, suppose that the number of hours per month that college students volunteer is normally distributed with mean 2.8 and standard deviation 6.7. Okay. Something I didn't mention about the central limit theorem, if you start with a normal distribution, you keep a normal distribution. That's the good news. So if you have a small sample size, but you started with normal, you're still okay, you still have normal. If you start with a not normal distribution, and you have a small sample size, there's no guarantee. But if you have a large sample size, you're still normal. So you either have to have a large sample size, or you have to have a start of a normal distribution, and then you're good. Or if you have both, that's even better. Okay, so for the following questions, do all of the following. Write down the indicated distribution. Do you remember last week I said that there were 4 things to do and I only told you 3? So now we're going to have our 4th. So first, write down the indicated distribution. Second, sketch the diagram. Third, answer the question. And fourth is state whether the normality assumption is needed. So let's do A, B, and C. So notice, I want to remind you because it's a promise. You will get a test question like this on the midterm. That will happen. So make sure you follow along, and I'm going to have you do these 4 things. And how many are you going to decide to do? And what I found is that I'd say half the class doesn't do 4 things. They forget one of them. So I want to tell you, there will be 4 things. That's a promise. Got it? Okay. I usually just copy and paste this little piece, write down the indicated distribution, sketch the appropriate diagram, answer the question, and state whether the normality assumption is needed. I copy and paste that into the midterm. So you're going to have to do that. So total, how many things are you going to have to do for problem number 1? Okay, not 4 because there's an A, B, and a C. That's a hint. 3 for now? Nope, not 3 either. Not seeing it. 12. 4 for part A, 4 for part B, and 4 for part C. Okay, so we're going to have a lot to do on this. This looks like a short question, but it's a long question. Okay, so the first thing is, if a college student is selected at random, what's the probability that that student volunteers at least 5 hours per month? Okay, so notice we only have 1 student this time. So what we can do is we can first write down the normal distribution. And the distribution, we say x tilde n. Let me write down actually 1, because it's the first thing to do. X tilde n, the mean was 2.8 and standard deviation was 6.7. 2.8 comma 6.7. That's the first thing to do. Any questions on that? That's because we have a single student. Okay, any questions so far? Okay, sketch the diagram. Hopefully you all know what the picture is going to look like. Every picture looks, ooh, that was awful. Every picture looks the same. Let's be a little more careful this time. That's good enough. I think I did better last week on this distribution thing. There we go. You get a nice normal distribution. And then we want to find out the probability there are at least 5 hours per month. The mean is 2.8. And at least 5 is over here. Let me go to 2.8. And then I want to shade. Maybe I'll shade in blue. Any questions on number 2? I should write number 2 here. I recommend actually numbering them, because if you number them, you won't forget, because you'll know there's going to be a 1, 2, 3, and a 4. Any questions on that? Now I got to write it on my paper. So we have 2.8, 6.7, and greater than 5. Okay, now part C is answer the question. So to do that, we need a calculator. And hopefully from last week, we know how to do this. This is actually a complete review of last week. So I'm going to go to new share, grab that calculator, and then let's clear out what we had. Now I want to go to second distribution. We want to find an area, so that's normal CDF. We're going to have a 5. And the upper is a bunch of 9s. And then 2.8. And then the standard deviation was 6.7. of 6.7. And I paste. Any questions before I move on? Before I click paste? Enter. And enter again. And there's our probability, about 37.3713. So let me go back to my paint. So that was number 3. 0.3713, I believe. Any questions on that? Okay, and now we have number 4. Was the normality assumption needed? So first thing, do you know what the word assumption means? I've noticed that a lot of students have trouble with that word. What does it mean? Put in your chat box what it means, what the word assumption means. Hypothesis, actually it's a little different than hypothesis. It's to believe something is true, not always believe actually. It's to say something is true, even though it may not be true. Okay? By the way, that is not a good thing to be able to do. What are the first 3 letters of the word assumption? And then that will tell you how often you want to make an assumption. Got it? Okay? In fact, there's a big joke that assume is to make an ass out of you and me. Because you don't want to have to make an assumption. Do we have to make the assumption that the distribution is normal? When it said suppose, that's an assumption. Do we need to make that, or can we ignore it? That first little paragraph. The answer is yes. So the normality assumption is needed. And that is because only a single individual is being surveyed or selected. Okay, there is no central limit theorem for just a single individual. So you don't get a sample size of 1 is never good for getting a normal distribution. So we have to assume we had a normal distribution. Any questions on that? Any questions? Yeah, that was 4. Sorry, I didn't put the number 4 in. Any questions on 1, 2, 3, or 4? So there's 4 things to do on these kind of questions. Okay, I'm going to erase this one and go to B. Okay, B, if 55 students are selected at random, what is the probability that they average between 3 and 4 volunteers hours per month? Okay, so let's answer the question. And the first thing we're going to do is number 1. And the first thing to look at is we're not looking at X anymore. What's our variable? The key word here is what is the probability average between 3 and 4? So what is the variable? Not the number, but the variable. What letter are we going to use? And it's not even a letter, really. Anyone know? It's X bar, because X bar is the average of the sample. And X bar, we can say tilde, normal distribution. The mean will be mu sub X bar, but mu sub X bar is mu. Does that make sense? So that's just 2.8. And the standard deviation is sigma sub X bar, which is not sigma. It's sigma over the square root of n. So that's sigma, which is 6.7, divided by, and I'm going to write root n because there's no root button on my keyboard. So root, and n is 55. So let me ask you, are there any questions? Any questions on that? In fact, I'm going to write over root 55. Put in my paper because I need to get ready. Okay, now number 2. Number 2 is to sketch the picture. Picture is always going to be normal in this chapter. Beautiful normal curve. That one's better than the last one. Okay, the mean is supposed to be 2.8. We want to find out the probability between 3 and 4 are going to volunteer. They're going to volunteer between 3 and 4 hours a month on average. And let's put some numbers in, 2.8, 3, and 4. And then I can shade between 3 and 4. Any questions? Any questions on that? So it's definitely going to be less than 50%. It might be much less, we don't know. But it's going to be less than 50%. Is this clear? Okay, so what we're going to do now is use our calculator. So let me go back to New Share, Calculator. And I can go second distribution, normal CDF. My lower is going to be, so I lost it, uh-oh. My lower is going to be 3. My upper is going to be 4. Mu was 2.8. And the standard deviation is 6.7 divided by the square root of 55. So I'm going to stop for a moment. Any questions? Any questions on these items? Notice the over root 55. Usually about half the class forgets that. And hopefully you don't. Okay, if you're using the central limit theorem, which we are, then we know that sigma sub x bar is sigma divided by the square root of the sample size. Then I can go to paste and enter. And you get about 32%, 0.3204. That's number 3. Three, 2, 0, 4. Okay, next is number 4. Was the normal distribution, normal assumption needed? Did we have to make that assumption, or can we get away without supposing the original distribution was normal? What is the key to this? The normality assumption was, what do you think? Okay, so the answer is not needed. Since the sample size was 55, which is certainly greater than 30. The central limit theorem tells us it's a normal distribution, or guarantees that the sampling distribution is normal. Right? And remember, the word guarantee does not start with ASS. That's a good thing. So you want to be able to not have to make an assumption. You want to just say, I know this is correct. And if you have a sample size of size 50, if you have a sample size 55, then you know your calculations are correct. Whereas on the part A, we had a sample, we didn't have a sample size, we just had one person. And we have to make that assumption, which we don't want to have to do, but there's no choice. Any questions on this? Any questions? Okay, let's do part C. Okay, find the IQR for the sum of 15 randomly selected college students' volunteer hours. So for this one, we're going to find the sum of 15 students. Now, who from algebra remembers the notation for sum? You're adding up a bunch of numbers, it was a letter you used, and it wasn't an English letter. Anyone remember? Epsilon's a good thought, but it wasn't. Epsilon's for a small number. Do you remember that? It happened in your algebra class at one time when you took algebra, and that means sum. So our variable now is going to be the summation of x instead of x bar. And then I can write tilde n. And now the mean is not going to be 2.8. It's going to be 2.8 times 15. Because if the mean of an individual is 2.8 and you're taking 15 of them, you would expect 2.8 times 15 for the sum. Does that make sense? Because if you hit the mean for each one, it's 2.8 times 15. And the standard deviation will be 6.7 times the square root of the sample size, 15. Any questions on that? That was number 1. Any questions on that idea? Okay. Number 2 is to draw the picture. By the way, number 1 is not only number 1, but it's the number 1 most forgotten thing to do on the midterm. So please don't forget number 1. Got it? I'm going to ask you to do it. It's not that hard. And if you do it right, you're much, much more likely to get the whole problem right. And if you do it wrong, you're very likely to get the rest of it messed up. So let's do number 2. Number 2 is to draw a picture. Always the hardest part for me because it's not easy to draw a line like that with a normal curve using a mouse. Not too bad. Okay, 2.8 times 15 is what? 1.4 times 30, 42. Okay, I believe, right? Sound right? 14 times 3, 30, 42, yeah. So that's 42. And we want to find out that the sum, we want to find the IQR. Do you remember what IQR means? What it stands for? That happened in chapter 2. Yeah, Q3 minus Q1. Q3 minus Q1. If you do Q1 minus Q3, you'll get a negative number. So it's Q3 minus Q1. Or you could say it's the numbers from Q1 to Q3. That's another way of saying it. So I'm going to shade in the IQR. And notice that this area is 0.25. And this area is 0.75. Any questions on that? Okay, and the first bit is, we'll call it Q1. Is the first quartile. The mean was, again, that was what, 42? And the next one is going to be the third quartile. And there's your picture. Anybody lost on that? Any questions, Josh or Megan or Rosa? Or Josephina? Sorry. Okay, so now let's do number 3. So let me write down 2.8 times 15. That's just 42. And 6.7 square root of 15. And we want IQR. So I'm going to share my desktop, go to my calculator. And so to find the IQR, what do I go to now? To find Q1, for example. Yeah, that's going to be inv norm. Because we're given an area, we want to find the value of x, or in this case, sigma x. So we're going to go inv norm, and the area for the first bit is 0.25. Mu was 42. Sigma was 6.7 times the square root of 15. Any questions so far? Paste, enter. Okay, that's Q1. Now let's find Q3. So I'm going to go back to distribution, go back to inv norm, and all I have to do is change that 2 to a 7. Everything else is the same. Paste it in, hit enter. So now we just subtract 59.5023267 minus 24.47. Sorry, 0.4976733. You don't have to take it that many decimals, but I figured I might as well. And you get about 35. 35.00. And there's your IQR. So let's pause share or new share. So number 3 is the IQR was equal to 35. For number 4, now, do we need to make that assumption of normality? Was that necessary? Or does the central limit theorem tell us it is normal? What do you guys think? Yeah, and why? So Josephine, you're right, we need to assume it. And why? So we need to assume it's a normal distribution. Yeah, exactly. Less than or equal to 30. Because 30 is not enough either in our class. You need over 30. So the normality assumption was necessary since the sample size was 15, which is less than 31. Any questions on that? So you can either say less than 31 or less than or equal to 30. Any questions at all on that? Okay, so this is kind of the standard question. I thought I'd give you one like this. Most of them are very similar. It's just kind of the way you go. I want to give you a nice little example in the real world. Okay, that's kind of real world too, but a money example. Josh and Megan and Josephine, are any of you business majors or business type majors? Okay, Jacob is. Okay. Half business major. Okay, so we got some. We got half business, half of the group. Okay, we got business half and no. So we're gonna do a little business example. Okay, and even if you're not a business example major, it'll actually will help you in the long run. Actually, I don't need to share. What I need to do is get rid of this whole question. Okay, so let's suppose, and again, it depends how you look at it for this particular example. Let's write it out. That the average return on the stock market is 9%. So 9% profit. And the standard deviation is 15%. Okay, so what that tells you is that in the long run, the market goes up, right? But from year to year, it might go down. Often it goes up a lot. This year it's going up a lot, for example. It fluctuates from year to year. And the business majors better know that, right? Okay, and the non-business majors probably do also. So what I want to do is we want to compare the difference between investing in a single stock, and we're just going to say randomly selecting a stock, and investing in the S&P 500. And we're going to make an assumption. We're going to assume that the stocks are independent, which isn't a great assumption, but let's just do it just for this class. So find the probability that you will lose money investing in a single stock. Okay. Oh, I guess up here I need to write assume normal. Any questions so far? Okay. So we want to see what's the probability you're going to end up losing money. So the first thing is what we can say is that for this one, X is normally distributed with mean, I'm just going to let percents be the units, 9, column percents, and we'll be all right. And standard deviation 15. Any questions so far? Now what we can do is we can draw our beautiful picture. Except that's not so beautiful. Let's try again. That's a little better. We have a normal distribution. We know that the mean is 9. If you lose money, what does that mean? What are we looking for a probability of on this picture? Off the chart, no, not negative 9,999. You don't expect to lose 9,999%. I mean, yeah, that's losing money, but in terms of losing money, it means you are to the left of 0. 0 is break even. That's going to be here somewhere. Let me put in the numbers. So this is 9, and this is 0. And what we want to do is we want to find out the probability you're going to lose money. And there's a lose money area. Did I lose you on that? Because I saw you were doing different stuff. So it doesn't have to be off the chart negative. It just has to be negative. If you lose 0.5%, you still lost money. Any questions on that? Okay, well, this is quite easy now because this is a simple little probability question. So I can go to my calculator. And let me write this down. And 915. Okay, and now let's go to the calculator. And I can go to stat. Oh, sorry, not stat. Let's go to second, distribution is what I want. Normal CDF. -1 E99 works. I like to, just to remind myself, I like to put negative in a bunch of nines. It's the same thing. The upper is going to be 0. Mu is going to be 9. Sigma is 15. Paste and enter. Okay. So if your entire education depended on it, do you think you should invest in a single stock? Your whole education money. Okay. Probably not, because you have a 27% chance of losing money. Okay, so we call that a high-risk investment. Any questions on that? Doesn't mean you lose everything, but you do lose. Okay, now comes the next question, which is the crux of the use of the central limit theorem, or one more use. Okay, if you invest in the S&P 500 index fund, now what is the probability of losing? Okay, so if you don't know what that is you pool your money with a whole lot of other people, and you end up buying a little tiny piece of 500 different stocks. We're going to assume they're independent. That's not a great assumption, but I'm going to make that assumption. So how does that change things? The main change is on number 1. Number 1, we're not looking at X anymore. Now we're looking at an average of 500 stocks. So now we're going to look at, I'm going to write X bar, easier to type. Tilde N, the same mean 9, but now the standard deviation is going to be 15 divided by the square root of 500. Any questions on that? Have I lost you? So that's the central limit theorem. It says that we can look at this as a new standard deviation with a 15 over root 500. That's called the standard error now. Okay. So now what we can do is draw our picture. Picture is going to be the same. The scale's different, it turns out. But you still have a normal curve. We still have a 9. 0 is going to be much farther to the left because the standard deviation is so small. And I purposely made, or kind of purposely, made my normal distribution shorter. Actually, it should be the other way. It should be taller. But that's all right. It's farther away. And now this is a 9. This is a 0. And I want to find that area to the left. Any questions? So it's the same picture, it turns out. It's just a different standard deviation now. Okay, so now we go ahead and let's look at the calculator and see what it gives us. So I'm going to go second distribution. And an S&P 500, by the way, if you didn't know, it invests in 500 of the main stocks. And index funds means that you're kind of pooling with everybody else. So business majors, if you don't know, you should know about it. Everyone else, it's a good thing to know too. Okay, and we're going to go to normal CDF. The lower is still negative 9,999, the upper is still 0, the mean is still 9, but now the standard deviation is 15 divided by the square root of 500. And remember, there was a 27% chance of losing money if it was just one stock. On the other hand, if we have 500, what's the percent chance of losing money? Yeah, 0. So it changes everything. And what they say in business is a good financial plan diversifies. And the reason why you want to diversify is because the Central Limit Theorem guarantees a smaller sigma sub x bar, which means you have a much smaller chance of being far to the left of the mean. Okay, what you can't do is you're not going to make huge amounts of money, but you're not going to lose either. You're going to make very close to 9%. That's what's going to happen. Okay, and if they're independent, so S&P 500 isn't quite independent, but if you can do a diversification strategy, you get independence, and then you will be basically guaranteed not to lose money. And that's pretty good if you're investing. If you just like gambling and you like the highs and lows, then it's a terrible idea. But if you want a very safe investment, that's what you do. Any questions at all on that example? Okay, so by the way, was it okay to use, did you need the normality assumption for the question about the S&P 500? What do you think, yes or no? Did you need the assumption? Yeah, you don't need it because 500 is much bigger than 30. So under anybody's criteria, you're good. The one assumption you need is independence. Okay, we're about out of time, so I want to give you a secret word. Let's do it in green. So the secret word of the day, it's actually 2 words. Standard error, which is the standard deviation of the sampling distribution, because that makes all the difference in terms of probability. So that's the secret word of the day. And what I will do, as always, is I'll stick around answering questions. I'm going to unmute you. So if you're talking, by the way, I'm about to hear you.
Cool, because you're pressured to do it, and you got to be here at a certain time. I've been thinking of that too.
Are there any questions at all? Any questions at all about anything I did or anything else? Double reminder, make sure you do that online exam because that's important.
Wait a minute.
All right.
Cisco. He's talking about who's it? He's like, it's Cisco. I'm Gordo.
Gordo.
I love. I don't know Cisco.
I don't know Cisco.
This ain't Beetle.
I always call him Gordo in front of his friends.
You ever talk to Beetle?
Here we go.
Yeah, he's such a fucking.
He's a weirdo, huh?
He's a fucking.
Better. Especially in zero profanity there. Any questions at all about anything that we did? Any questions? Again, unmute yourself. We're getting some background sound that was not necessarily so nice. Any questions at all? And again, yeah, it was you. somebody in your background was talking with lots of profanity. And I try not to use profanity in class. We're not children or anything, but still.
I have a question. I just want to make sure we're using the X bar whenever the sample size is really larger than 30 in this class. Is that right?
Okay, so not quite. We're using X bar anytime you have a sample. You have a sample and you're interested in the average or the mean. What we're using for larger than 30 is normal.
Okay.
So if you don't have larger than 30 and you don't know the distribution originally was normal, you can't do any of this. You can't draw a normal curve. You can get sigma sub X bar and you could get mu sub X bar, but you can't get the normal curve, which means you can't compute a probability. Because if you don't know what the distribution is, you're lost. Does that make total sense?
Mm-hmm.
Okay, good question though. Very good question. Other questions? Any other questions? Okay, so practice a lot. Make sure you ask questions on the Q&A form now. Just a note, I'm going to start reading the projects tomorrow. I finished the grading your discussion posts today. That didn't take too long, but I taught all day, so I didn't have a lot of time. But tomorrow I'll have some time. So I'm going to start doing that. Because you only submit, one for group, I give you feedback to the person who submitted it. So if you're the one that submitted it, it is your responsibility to share my feedback with your partners. Okay, I give the grade to everyone. Everyone gets the same grade in your partner group. But the feedback only goes to the person submitted, so please share it. Whether you email or call or whatever it is, make sure you share the feedback. Because my feedback can only get sent to one. Can't get sent to everyone, it turns out. It's just one of the problems with the system. Okay, so, and I apologize for that, but it's what I have to work with. Okay, any other questions? Any other questions? Again, if not, we can say goodnight. If you have questions, I'll be happy to answer them. Okay, have a good evening. Have a good night. Any questions? Okay, for all of you watching this as an archived lecture, don't forget secret alert is standard error. And please post on the Q&A forum if you do have any questions, and I'll be happy to answer.